4.4 correlated angles. So again, you have a notebook sheet that has a bunch of circles drawn on it. And let's look at that very first circle. It's a circle you've dealt with before. We can call that angle A. So it's a circle showing angle A. It extends from the initial arm here along the x-axis, and it's just kind of an arbitrary distance. That is angle A. The coordinates of point P that go with angle A are, in the unit circle, what are its coordinates?
Cosine, sine.
Cosine, sine. Okay, so we're going to be looking at a whole bunch of other angles there, 4 other angles that we can relate back to A, and these are going to be called correlated angles. Okay, so we know that A has a related angle in each of the 4 quadrants. There's one angle related to A, and now we have correlated angles. So your first circle down below is the circle showing an angle, and I'm not sure if you have the words there. Do you have the words there? A less than pi over 2. So those are the words that belong there. We're going to draw an angle that is A less than pi over 2. Well, pi over 2 is up here, a 90-degree angle, pi over 2. And we're going to go back A. Okay? So what we have drawn here is pi over 2 minus A. That's the angle in question. So again, mine kind of look like a 45-degree angle. Don't imagine that it's a 45-degree angle, okay? It could be any angle. It can be any angle. And then maybe I'll even change it on the diagram because it's a bit deceiving. Let's make A, you can do whatever you want, but I'm going to make A skinnier so that we don't confuse it with a special angle like 90 or even 30. So we've gone up to pi over 2, and we're going to come back A, leaving us with an angle measure of pi over 2 minus A. So if we take those coordinates then, the coordinates of the point that go with pi over 2 minus A are going to be the cosine of pi over 2 minus A, and we got to put that in brackets, comma, the sine of pi over 2 minus A. And now we can think about our previous circle that we drew, and we find out that the coordinates, if we're at cosine A, sine A, and then we basically are just taking this angle, we're taking this right triangle, and we're basically flipping it to be tall and skinny instead of short and wide. And what actually happens is, as high as the sine of A is here, that's the same distance that's going to now be our x coordinate. And our y coordinate, our y coordinate was sine of A. Now that's going to be our x coordinate. And our x coordinate was the cosine of A. But now that's the same as the height along our y coordinate when we do pi over 2 minus A. So all that to say, this relates back to our x value is now the sine of A, and our y value is now the cosine of A. And so you have a correlation, you have these correlated angles, the cosine of pi over 2 minus A. If you can ever represent an angle as pi over 2 minus A, then you know that the cosine of that angle is the same as the sine of A, which will often in your practice problems relate back to a special angle that you will have memorized from your unit circle, and you'll know the exact value of that original angle, the sine of that angle. That will make more sense once we practice it. Okay, moving to the right, I will draw the circle. You see if you can describe the angle. So still have pi over 2. And from here to here, we have the angle A. So what would be the name of this angle? If here we have pi over 2, and then we go A more, pi over 2 plus A.
Wait, what?
So we went this purple angle right here. We go pi over 2 is 90 degrees, and then we kept going. A,
Plus A.
A more. So we have pi over 2 plus A.
No.
So the coordinates that we're working with then are the cosine of pi over 2 plus A. Put your angle measurement in brackets. And the y coordinate of the corresponding point is the sine of pi over 2 plus A. And then we can think back to our original triangle, our original angle. And actually it's helpful to go just to the diagram before here. And you can see that the y coordinate is the same, but the x coordinate is the opposite of what we had here. So we can see that we go to the y coordinate being the same, so the y coordinate is cosine of A, and the x coordinate is the opposite, so it's negative the sine of A. In our third box, we have another circle. And there's the angle A. So the question is, what would we call this angle? We've gone to 3 pi over 2, and then we went back A. So we're just looking at 3 pi over 2 minus A. Coordinates, again, without doing any thinking or math, it's just knowing that your x-coordinate corresponds to the cosine of that angle. So it's the cosine of 3 pi over 2 minus A. And the y-coordinate corresponds to the sine of that angle. So we have the sine of 3 pi over 2 minus A. And then we want to relate this back to being expressed in terms of just angle A. So let's think about this. Well, if we look at the diagram that we had up here, we now have, instead of just having a negative x value, we have a negative x and a negative y. So we're going to take our coordinates that we had, maybe these coordinates, and they're both going to be negative. So now we have negative the sine of A, negative the cosine of A. One more diagram, one more circle, one more angle to talk about. The angle is, all right, here's angle A, right there, just a little one. And we're looking for a name for this angle that goes all the way around. So that ray, that angle would be 3 pi over 2 plus A. So we're going to 3 pi over 2, which is down here at 270 degrees, is 3 pi over 2 radians, and we're adding A. So the coordinates, the cosine of 3 pi over 2 plus A, comma, sine 3 pi over 2 plus A. And in this set of coordinates, our y value, still negative, but our x value is positive. So we're looking at positive sine of A, comma, negative cosine of A. Okay, there we have a whole bunch of correlated angles. Now between related angles and correlated angles, you can really find, you can really reduce almost any angle down to sine A or negative sine A or cosine A or negative cosine A. Okay, and from that we need to also then find the tangents of each angle. So you have 4 boxes at the top of your next page where we're going to basically summarize our information and give you a reference to come back to on your practice problems. So in that first box, we'll work with pi over 2 minus a. So in the first box, you've got the cosine of, and then in brackets, pi over 2 minus a is equal to, and you can go back to your notes that we just took. It's from the first box. That's equal to the sine of a. The sine of pi over 2 minus a is equal to the cosine of a. And the tan of pi over 2 minus a is equal to the sine over the cosine. So I'm going to right away skip to what we've reduced it. So the sine of pi over 2 minus a is the cos of a. The cosine of pi over 2 minus a is equal to the sine of a. And so this is simply the reciprocal of the tangent of a, which is the cotangent of a. Okay, so the tan of pi over 2 minus a correlates to the cotangent of a. If we go to the right, we may as well do this kind of in the same order. If you go to the right, top right box, we'll work with pi over 2 plus a. So we've got the cos of pi over 2 plus a. We decided that correlates to negative the sine of a. The sine of pi over 2 plus a corresponds to the cosine of a. The tan of pi over 2 plus a is the sine of pi over 2 plus a over the cosine of pi over 2 plus a. So we've got cos a over negative the sine a. So now we have a negative, and it's still the reciprocal of tangent, which is cotangent. So we're looking at negative tan of a. In our next box, bottom left, we can do 3 pi over 2 minus a. So we've got the cosine of 3 pi over 2 minus a. And that correlated to negative the sine of a. The sine of 3 pi over 2 minus a related to the negative cosine of a. The tan of 3 pi over 2 minus a is sine over cosine. So our sine of 3 pi over 2 minus a reduced was negative the cosine of a. The cosine of 3 pi over 2 minus a is negative the sine of a. So we have cosine over sine, which is cotangent, and we have a negative over a negative, which is a positive cotangent of a. One thing that we can do here too is you should be thinking about the cast work that we know about. So if you have your circle, wrong way. So this indicates which trig ratios are, which primary trig ratios are positive in which coordinates. So they're all positive in quadrant 1, which is why up here in pi over 2 minus a, they're all positive. Okay? In quadrant 2, only sine is positive. So that's here. The sine of it ended up being a positive value. Am
Okay, so
I saying that right? Is this wrong? Did I draw this wrong?
you did. Alright. You put cot A for cos over
All
sine,
positive.
and then tan for cos over sine in another spot. Alright, look.
quick correction in your notes here. This should be the cotangent of A, negative the cotangent of A. Move down to our bottom box where we're looking at 3 pi over 2 plus A. 3 pi over 2 plus A, we've got cosine of 3 pi over 2 plus A, sine of 3 pi over 2 plus A, and then the tangent of 3 pi over 2 plus A. The cosine of 3 pi over 2 plus A from that bottom box reduces to the sine of A. The sine of 3 pi over 2 plus A reduces to negative the cosine of A. And the tangent, which would be sine over cos, ends up being negative the cos of A over the sine of A, which is negative the cotangent of A. So those are your notes to refer back to as you're looking at your practice problems and simplifying and finding the exact values for these correlated angles. So let's go for example 1 here. Example 1 gives us cosine of x plus the cosine of pi over 2 minus x minus the cosine of pi over 2 plus x minus the cosine of negative x. So now we take on all of these things that we know in order to reduce this and simplify it. Cosine of x just comes down. It's cosine of x. Can't reduce that any further. But this correlated angle, pi over 2 minus x, the cosine of that is just plus the sine of x. And then we have minus the cosine of pi over 2 plus x, which is negative sine x, but be careful because we are subtracting it. So we have minus a negative.
Oh, yeah.
So we'll reduce that further in our next step. And negative the cos of negative x, well, the cos of negative x is equal to the cos of x. So that comes back from last lesson or even previous lessons. Okay, we can reduce this further. We end up with the cos of x plus the sine of x plus another sine x minus the cos of x. So we have plus cos x minus cos x, that's 0. And we have 2 sine x. Sine x plus sine x is 2 sine x. Okay, so it's just an application of those correlated angles. That was simplifying for when we don't know the angle, okay? In example 2, we know the angle, okay? I'm going to slide over. I think I can fit it here onto the right. Example 2 asks us to evaluate. So we're actually going to be getting an exact value. We have the secant of 3 pi over 2 plus pi over 3. So they've already split this angle into 2 angles. It's a double angle, I guess you could call it. I think we get into that a little bit later. But we know that we can, the first step is going to always be take out their secondary trig ratio. So instead of writing it as the secant, we're going to flip this over to its reciprocal primary trigonometric ratio, which is cosine. So we have 1 over the cosine of 3 pi over 2 plus pi over 3. And it looks a little messy, but we're going to get there and we're going to get back to the secondary trigonometric ratio also. Now, from our notes, we know that this is a 3 pi over 2 plus a situation, but we know that a is pi over 3. So the cosine of 3 pi over 2 plus a is the same as the sine of a. So this denominator reduces to the sine of pi over 3. The sine of pi over 3 is a special angle in your unit circle. You have the exact values memorized, at least close to memorized, or you will by tomorrow maybe. The exact value of sine of pi over 3 is the radical 3 over 2. So our numerator is 1. Our denominator is radical 3 over 2, which reduces to 2 over radical 3. So we were able, using our correlated angle formulas, identities, to reduce and simplify and actually find the exact value of this awkward statement. Example 3. This type of question comes back again and again and again. Basically, it gives you important information. It tells you that the sine of pi over 5 is approximately 0.5878. So what it's telling you is that when you are able to split up the angle that it gives you, you're going to be left with one of the special angles and pi over 5. So some way or another, pi over 5 is going to be added to or taken away from another angle in order to make the angle, in this case, in A, 3 pi over 10. Okay, so basically we want to be able to split 3 pi over 10 into two angles so that we can get it looking how we've been working. In order to do that, I first want to draw a unit circle. I want to think about where 3 pi over 10 is, okay? Well, this is pi over 2, so this would be half of a pi, and this is 3 pi over 10. This is less than half of a pi. So this is somewhere in quadrant 1, maybe here, okay? So what I can do then is I can think of what this splits into. It's going to be pi over 2 minus something. It's going to be pi over 2 minus a. Okay, we don't know what a is yet, but I can tell you it's going to be pi over 5. We're going to figure that out once we get there. So what you have to do next is don't write an equal sign because this statement is somewhat unrelated, but we're going to figure out what a is. We know that 3 pi over 10 is equal to pi over 2 minus a. That's what we just drew here. Pi over 2 minus a.
Where is A in all of this?
A is the unknown angle. It's the piece that we don't know yet. But we're trying to figure out what it is because we know that as soon as I can express this angle as pi over 2 minus a, then all of a sudden I can use my correlated angles to figure out its exact value.
So it's sine pi over 5 and then A be equal to that?
So we're basically just using this to figure out what a is, okay? So pi over 2 minus a is 3 pi over 10. So we can do this algebraically, okay? We can add a to both sides to get a on the left and to get it positive. And then we could subtract 3 pi over 10 from both sides. So we go a equals pi over 2 minus 3 pi over 10. Now in order to add and subtract fractions, I want to have a common denominator. So here I'm going to take pi over 2, I'm going to multiply top and bottom by 5. It's going to give me 5 pi over 10, right? 5 pi over 10. So I have 5 pi over 10 minus 3 pi over 10, that's 2 pi over 10, which reduces to pi over 5. Okay, all that just so that we can write the cosine of 3 pi over 10. So now we're kind of going from here all the way down. We're going to have the cosine of 3 pi over 10 is equal to the cosine of, we're starting at pi over 2, and we now know that a is pi over 5. Once you've done this a few times and you get good at it, you won't need to do all this section, all this written work in between, okay? You'll probably just write this right here, 3 pi over 10 equals pi over 2 minus a once you figure out what quadrant it's in, and then you can probably skip right down to a equals pi over 5, okay? This is the algebraic figuring it out, but look at the problem that they gave us. They told us that that's going to be the angle that we're working with, Okay, so now we look at our correlated angles, our identities that we took our notes on, and we find out that the cos of pi over 2 minus a is just equal to the sine of a. In this case, the sine of pi over 5. And we're told that the sine of pi over 5 is approximately 0.5878. Okay? So we were given this information up here, and we were able to evaluate this statement. How? By finding it as an expression of correlated angles, finding out what quadrant it's in order to use the right formula, and then reducing it based on that information. Okay? We're going to see that again in the second example there in B, example 3b. This time we have the cosine of 7 pi over 10. So again, we're going to think, where is this angle of 7 pi over 10? Well, it's bigger than pi over 2, because that would be 5 pi over 10. But it's not as big as pi, because that would be 10 pi over 10, so it's somewhere over here.
It's 4 pi over 10 further.
2 pi over 10 further, right? If this is 5 pi over 10, and we need 7 pi over 10. So we're in a situation here where you would be adding 2 pi over 10. So let's do that first of all. So we're at pi over 2. So we're going to off to the side. And if you want to do it off to the side, you can. You can kind of just do your work over here and say, okay, 7 pi over 10 is equal to pi over 2 plus some angle A. And then this part you can kind of just think about in your head. Pi over 2 is 5 pi over 10. So I need 2 pi over 10 more. So A must be 2 pi over 10, which reduces to pi over 5, which we already knew because that's the angle that they give us to work with. Okay, we have to show that it actually does match up properly. Now we can go back. Go back into our situation here, and we can rewrite this as the cosine of, instead of going 7 pi over 10, we're going to express it as pi over 2 plus pi over 5. And we can look to our correlated angles. We find out that the pi over 2 plus the cosine of pi over 2 plus pi over 5 is equal to negative the sine of A, which is pi over 5 here. And we know the exact value of the sine of pi over 5, the approximate value, sorry. It's right there. And we know this time we're just going to have a negative out in front. Negative 0.5878. Okay, this is the sine ratio. This is the cosine ratio for the angle 7 pi over 10. We found its approximate value without a calculator just by using correlated angles, and we were given one of the angle measurements. Last example there in your notebook, example 4, we are given that the cosecant of 2 pi over 7 is approximately 1.2790. We're going to use equivalent trigonometric expressions to evaluate the secant of 3 pi over 14. So you can be pretty sure that you're going to end up using this angle as your angle A. First thing we're going to do, we're going to work through to get your primary trigonometric ratio, but we are also going to draw this in the circle to see where we end up, okay? So if we've got our circle, 3 pi over 14, that's less than half of a pi, way less. It's a pretty small little angle here. Let's say it looks something like that. 3 pi over 14, so we're in quadrant 1, which means we're looking at pi over 2 minus a, okay? We're looking at pi over 2. We can express this angle as pi over 2 minus a. So if I take my work off to the side here, I go 3 pi over 14 is equal to pi over 2 minus a, okay? Another way to think about it here, I would just express pi over 2 as a fraction over 14. So that would be 7 pi over 14. 7 pi over 14 minus 4 pi over 14 would get me a. So a is 4 pi over 14, which reduces conveniently to 2 pi over 7. If you need to do the algebra on that, you can. You can express this fraction as a fraction over 14 and rewrite it and add a to both sides and subtract 3 pi over 14 from both sides and carry on that way. You will get that a is 2 pi over 7. So now I can express this as the secant of pi over 2 minus 2 pi over 7. Okay? Express as a primary trigonometric ratio. So we need the reciprocal here. We've got 1 over, what's the corresponds to secant?
Sine.
Yep, and actually, it looks like no. Secant goes with.
Actually, might go with cos.
Sine, cosine. I guess I could just look at my sheet. Secant goes with cos. It's 1 over cos. So we've got the cosine in the denominator of pi over 2 minus 2 pi over 7. The cosine of pi over 2 minus 2 pi over 7, that's pi over 2 minus a. So we look at our correlated angles there. And we get that it is, in the denominator then, can reduce to the sine of 2 pi over 7, the sine of a. And now we can flip that back into its secondary trigonometric ratio, its reciprocal ratio, which is now cosecant, because we have sine in the denominator. So we end up with the cosecant of 2 pi over 7, which is convenient because that's what they gave us to start with. So we have the cosecant of 2 pi over 7, which we know is approximately 1.2790. Okay, that one is a little bit harder because we had a secondary trig ratio that we needed to then flip into its reciprocal. So remembering which one is its reciprocal or checking back in your notes to make sure that you're doing it correct. And then using a correlated angle and then flipping it back into its secondary trig ratio, which is the same as what they gave us, so we knew what it was equal to. But again, find out where in your circle you're working with so that you use the right base formula. And your practice problems are there. From page 225. I think these questions are taken right from that page, numbers 1 through 10. Otherwise, you should double check because they're both listed there.